Okay, we're back. I said 1 hour, but I spent like 2 minutes, like chit chatting with my family. What's this? There is someone in here. Oh, zero. Oh, zero viewers. There was one people in here, and then zero. Okay. We lost the public, the audience. I don't know why. Maybe the person was like intimidated when I said there's one people in here, and then ran out. Well, anyway, we are stuck in the problem. I don't. When another thing, whenever you see the continued label in the image of in the thumbnail, it means that the previous hour it was a lot of struggle, and but we arrived to some days that we can use for the next video. Yeah, and that happened in the previous hour. Yeah, lots of tinkering, lots of try and error, and at the end we dissected the function with pattern matching to see the inner working. Uh, and the problems that are coming next in the upcoming chapters will be more challenging, and if you are, I don't know, I also will need to take the time to really to not intersect with my launch time, with our launch time, so I can't be pressured with that, removing that factor. And yeah, but it will become, I suppose, the upcoming exercises will be more challenging, but we will tackle the entire book. Don't worry about that. We will exercise the entire book. I don't know if we will be able to solve all the exercises. In here we are in really stuck. We are at risk of not solving this exercise, which is according to the book. It's critical. Whenever you see this mark, is exercise is critical for in the book. But I think also if we solve the exercise with pattern matching and we can't abstract with false rights or any other higher order function in about 15 minutes. I will take a. This is the last exercise in this chapter, so it is safe for us to take a look at the answers for these sections. There are answers at the end of every chapter, and I think we are in a good position to take a look for these answers in the case that we don't come up with the higher order function abstraction. But let's give it a try. Let's give it a try. Let's not surrender. Let's die with the boots on, like the Iron Maiden song. Okay, so we are troubled with traverse backup, and we have traverse. This is working. But let's start with this. Okay, let us click on run. Okay, 3, 2, 1. Now we need to reverse this list. If we reverse the list over here, it doesn't. This. Oh my God! We shall do a map and some. I don't know what happened with me today. Uh, from the very beginning, this I was like, I don't know, something happened. Okay, 1, 2, 3, but we are like going twice in the list, you know. And the book says that this is not cool. It is cool if there is no other solution you can arrive at. There is a function method in on lists. Also, yeah, that we can probably use, but I don't know how it will affect the function in terms of memory, because it goes like this: b, which is a list, appended. You see, it's the second one, this one, and you appended a, and this. Well, let us remove this so you can see the effect. Okay, now we have removed the reverse, and we should get 3, 2, 1 again. Okay, and now we can use appended. Okay, hopefully it works. Error. Running. Still running. Are we online? 7 minutes. It seems like Scala is getting some trouble. Some error. Nothing. Nothing happened. Seems like Scasti is okay. 1, 2, 3. We have okay. This is working. This works. We have our list. What we are not reversing the list, but we are using this appended, and I haven't seen the source code for appended, so I don't know how exactly it is like the book says, you know, efficient, still efficient or acceptable in efficiency, but we at least remove the reverse over here. So we have a working solution for traverse. We did it, you know. We should be happy. You should, whenever you are experimenting, this is computer science. I studied these topics because I love computer science. And if you are a scientist and are experimenting, this is our laboratory, the computer, and this comes from Robert Sedgwick from the algorithms course in Coursera. He says that I don't know if he read that from Donald Knuth, but our laboratory, it was from Robert Sedgwick. I heard it from Robert such he was saying that, and I am about to finish that course. That our laboratory is for this people studying algorithms with computers. So if you are a scientist and are doing experimenting, you will find errors. You will not always arrive to the solution right away. I mean, we are learning. That's why we are with the book, you know. But we need to celebrate when at least we have a working solution. This is like the ceremony. Should be at the end because, yeah. Now that we have traversed and our happiness has gone to the top, let's see if we can implement sequence. Only after that we can take the opportunity to implement this with higher order functions. And we are just getting an error that previously I don't understand that error, because once you understand it, you have the solution, right? Let's go with sequence. We also have this traverse in my eta object, companion object, but we did the same in the option, right? Or no? Oh, these were like outside. We didn't have any companion object over here. We said that we will be having a companion object. Now let's now that we have traversed, we can do the same and make the same as some people say that Albert Einstein said once, but expecting different results and doing the same stuff is insane. And we are about to do the same thing, which is copy and paste from the previous sequence. And let's remove one space. Let's also remove this, which, oh my god, this, I don't know, it was a lot of, I don't know, in the previous hour, if you saw that, it was an entire chaotic hour. I don't know what happened with me today. But let's not make any excuses and continue. We have sequence, ace of list, my either is. Where is sequence? We have a sequence over here. But there is another sequence. Yeah, this one. This is beautiful. I don't know how this will going to work. I don't know. Let's it should be the same principle. Oh, there's something different over here. List either. Okay. Okay. Ethers. And send them over the thing. Hope for the best. And how can we how can we let's comment this one, and now sequence, and now we need the headers. But yeah. Oh no, we didn't. I thought we removed this. Something is wrong with me today. I thought I did remove this. Thing is running, and we have 7-1. Aiders is, where is Aiders? 7-1. Yeah. That's probably what we should be down in the previous hour. How many times have we spent? 16 minutes. Plus, let's suppose we shall engage in pattern matching from the previous video, from the very beginning. 1.5 half an hour plus this 16 minutes. We will be within the hour, but don't think we should solve this exercise within an hour, because when the show is 1 hour, you know, like, well, it is not limited in time. I don't know. Because let's suppose we are in chapter 10, which is about monads. I don't remember. Or, you know, some challenging chapter 12, 15. It will be unfair for us to, you know, try to solve the problems in 1 hour and feel bad about it. It's silly. It's nonsense. We should be happy right now, today. We made it, and if, probably the next exercise I will allocate 3 hours if it's necessary. And yeah, so what can we learn? We have map 2, which, oh my god, we were using map 2 as a function over here, not as a method. In the method, object-oriented style method. That was a little bit some turbulence. Now this is great. This is amazing. But now, let's suppose we can devote 10 minutes, 5 minutes, because I really don't understand this error, to be honest. I don't know why it's giving us that error. So we will be, for sure, we will be taking a look at the answer for this. So let's, but if we take a look at the answer, we will still comment, so we can have a working worksheet to share, you know, for next chapter. But this is a new chapter, so we will start in blank. Okay, so we did it. Some will say, but you didn't do it in the cool style. All right, but I will listen instead to Peter Norvig, Mr. Peter Norvig. Here's my solution, and I should feel happy about it, right? But let's see at the solution the authors are providing and think, oh, my solution works. But this is interesting too. I learned that by memory because I really admire the guy Peter Norvig, and I will listen the man. You know. So let's remove these question marks to see the error once more. And if you are struggling with some exercise, maybe you are, I don't know, solving, I don't know, some kind of hard problem, just think that you should be experimenting and trial and error. As this is how life happens for ordinary people, says, where's that book? Yeah, this one, Mathematics for the Million. The guy says that life for ordinary people, it's all about, and I will be making videos about that book because it's, oh my god, I should, I don't know how I didn't encounter that book early, very early. I don't know, but I will do some videos so people that don't know the book exists will have the information. Yeah, but this, I have too much to do. Yeah, let's go back over this. Now let's see the errors. Errors are very welcome. Not found ACC. Not found ACC. Where is ACC? We don't have ACC over here. We have B, which is our accumulator. Now, this error, I don't get it. If there is anyone over here, some expert, there's no one here, you know, so you can comment. This is like you're missing this piece of information. So I will give 3 minutes thinking, and after that comment this function and stick with the pattern matching solution that we have arrived, and take a look at the answer to see what piece of information or how they were able to solve it. I like to learn. Okay, let's 2 minutes. Let's think for 3 minutes. And then 15 because it's very late and I would like to do some other. Okay, but I don't get it. This happened in the previous hour. This was the first error. What? Okay, right. It says found error E requires nothing. Okay, we can write nothing, which is a but the people will need you know, someone using this function will need to know the error. So we have our list, ace, all right, list, and TP. AB, this is the function, this is the list, this is accumulator, and it works because we have it over here. Where is it? Here. So this is the accumulator. But now we are applying F, and we are getting my ether EB. Why it isn't like this? Found error E required nothing. And we put this, and this is blind found any playground. Sorry, I am if my head is too close to the camera, because I need to read the thing. Any playground by either any nothing, and it is required nothing list B. That's why it says that it requires nothing, because it is expecting my ether nothing on the left, and a list B, and it should be any. I don't get this error, to be honest. Did we? Yeah, 5 minutes. I think it's safe for us to take a look at the answer, because I could spend the entire day in this line of code, and I don't know. I don't have the piece of information required to understand this part. In my opinion, it should be error, because you need to and it says error is of type E, which is over here, and yeah, I don't know. I don't know. For me, it should be this. Implement sequence and traverse for items. This should return the first error that's encountered, if there is one. It can be error by itself. Yes, this is true. Error E, found error E, and it is required. It is required. But the error is the same. It says found error E. And if we say left error like this, it still says found error E like this, and it says that it requires nothing. Probably there's something wrong here for this. Oops. I can't think of a solution because I don't get it. For me, this is the answer because we are just propagating the error. Yeah, I don't get unless you want to use look at this, it's saying left P. I don't get it. It is left all over the place. Look at this, left error. Case left error. Left error. We need to see to the answer that it is provided in the book for sure, and then right over here this is from the book, but I don't get this. Maybe we are locked and we are telling ourselves that you need to use for right. Maybe there is another way, but I don't know how the book can. Maybe it's a type annotation, but where? This is an A. This is either B, E or B. Look at this, E or B. And if it is left error, yeah, let's see the answer because there is no point in wasting the entire hour. I mean, if you can afford this book, just don't think twice. This is an insanely great book, and I'm about to reveal the answer because in the official GitHub repository the answer, and I am yet to read all this. Maybe over here it is. No, this is an elaboration of how we can use the functions that we have just implemented, which I will be reading in the week. Yeah, we are about to see the answers, but remember these are available in the GitHub repository, but I don't want to risk myself to see some answers from any other exercise. Look at this. These are for the option. This is variance, which it was like we did arrive at the same solution. We saw the answers for this at the end, but we did have the exact solution previously. In this 4.7, we have a solution, working solution, but it is not implemented in terms of other higher order functions. We have map2. Where is it? Map2 again. So if we had to use one above, we could have an option as you see. We could have used pattern matching. Yeah. You know, this is nothing wrong with this. 4.4 fall right. This is sequence. Maybe this will be the thing. Maybe, I don't know. Neil, I don't know. Look at this. This is sequence. This is different for us. We write the whole list of option sequence. Yeah, sequence. So the book have it. This is not in terms of travel. Oh, here it is. Here it is, A to A, which is identity. This is great. Oh, this is the first encounter with sequence. It is some nil. I want to see this now that we are taking a look at the answer. We have sequence, yeah, some list. Oh, that will be our problem because we have some list of MTA, and this worked, and they have some new, which is an empty list. But this is an empty list too of type A. Could we dash it? Could we dash? Well, we are still, they are using nil all over the place. We have arrived to my either. They went with the 4 comprehensions. Or else they did it with pattern matching too. Look at this. All over the place, because in here we didn't have get or else, so we did the same thing over here. Now, our nemesis. The pattern magic, the matter operation is for comprehension, which is fun too. Okay, this is a great book. Now we have sequence. Yes, it is. This is the size type signatures. The only change is our choice of an initial accumulator, right nil instead of some nil. They have this. Let's copy and paste to see. And in here they have like the same x to x, but let us see this as all right. Either oh, the time I couldn't. There is no way I can arrive with this. And I remember this from my previous lecture 2 years ago. Now that I see it, I forgot that the whole right itself, look at this, should be type annotated. They have a type annotation on this but they are more compact, and we will see why. They also have nil, but I think this is like the problem. Now we have error of type E, and Scala will infer nothing. Okay. Like not in this way, required, yeah. Once more. Okay. So yeah, it will be. I want. Where is it? Where is it? Here it is. Yeah, I didn't remember this part. You know, the whole right is annotated with this data type, because otherwise Scala was inferring that you need nothing. Yeah, in this list empty works. Okay, so it's not like nil. There was no way I could think about this. I didn't have this piece of information. The Scala needs this. I did it from 2 years ago. That I read again this. I solved this exercise on July 2022, and this 2 years ago I still see this. How do you like the song, the background music? I will augment the volume at the end so we can celebrate. But we have another great thing over here. Now we know for sure that all right is now I remember, because I did encounter this same issue 2 years ago. But how can you know? And probably I will ask this in the Scala Discord channel. How can you know when do you need to annotate these higher order functions? When do you need to assist the Scala system? Now there is another thing going on here. We have FA. Let's uncomment this. we have this part, but they only have this part, which is amazing. And this only reveals that we still have to. Where is it? Okay. Yeah, we don't need. We don't need. This is outstanding cool because indeed, you don't need to. If you already have map, this is great. You know, this is. I don't know. This is. Look at this. How beautiful is this? And probably this applies over here in our option over here. Probably I will record a video on extracting this to a map application. Yes, 5 minutes video. We have more content to create. This is great. This is great. Okay, so they have the function application. Probably this is related on us not wanting to think. Map to be in the function, and if there is an error, map2 will take care of that. So two things: the type annotation and how they use map2 without. How they leverage the map2 machinery to take care of this part, because it is already on map2. Okay, we are finishing this live stream. I am opening up this standing music. Well, at the end, let's annotate this. All right, should be annotated with from the book. We learned, yes, we did it. We implemented our little traverse. I am very happy with this. But we shall always strive for these abstractions. Where are they? This is great. Now some ending music. This is how our next videos are going to start, with loud music at the beginning, and then the exercise, and finish with this. You can acquire this song. Check the description in the video. Thank you very much, and see you with chapter 5. But I will finish reading the pending sections that we have, and then jump into the chapter 5. What happened to the person that was here? Thank you very much. Bye.